Our question 5th is a very important and a highly conceptual problem. In this problem, the students tend to make some mistakes which we'll try to avoid. We have a cylinder which weighs 14.8 kilograms when empty. When it is full with a gas, it weighs 29 kilograms and the pressure inside is equal to 2.5 atmospheres. At 27 degrees centigrade, during the usage of the cylinder, the weight of full cylinder reduced to 23.2 kilograms. We want to find out the volume of gas which has been used up and the pressure of gas inside the cylinder finally. Now, in order to proceed with this problem, first of all, let us try to find out the weight of butane present initially. Butane initially is equal to total weight of the cylinder minus the weight of cylinder when empty. It is equal to 29 minus 14.8, which is equal to 14.2 kilograms. This is the weight of butane which is present inside the cylinder in the initial conditions. So the moles of butane present initially is equal to 14.2 into 10 power 3 grams upon 58 grams. Now we will try to find out the volume of cylinder or the volume of butane present initially. Since initially the whole of cylinder was full with butane, so volume of butane is equal to volume of cylinder. We can find out this by PV is equal to nRT equation. We have pressure equals 2.5 initially into volume is equal to N, which is equal to 14.8 into 10 power 3 upon 58. This is the number of moles into gas constant, which is 0.0821 into initial temperature, which was 27 degrees centigrade. We converted into Kelvin, which is 300 kelvins, and hence we get the initial volume or the total volume of the cylinder equals 2.4 into 10 power 3 liters. This is the volume of butane present initially. This can also be taken as 2.4 meter cube. Now, even after the usage, the volume of the cylinder will remain constant. We can find out the weight of gas which is left inside the cylinder after use. This can be calculated by using 23.8 minus 14.8, or rather 23.2 minus 14.8, because 23.2 was the initial weight of the full cylinder and 14.8 is the final weight of full cylinder. So this comes out to be equal to 8.4 kilograms. Now, since volume of cylinder remains constant, we have the final pressure of the gas inside into the volume which we got as 2.4 into 10 power 3 is equal to the number of moles, which is equal to 8.4 gram into 10 power 3 grams upon 58. This is the weight of gas left inside the cylinder after usage. It is 8.5 kilograms, that is 8.4 into 10 power 3 grams. So dividing it by 58, which is the molar mass, we get the number of moles into 0.0821 into the final temperature, which is again equal to 300, because the temperature inside the cylinder will remain constant. On solving this equation, we get pressure equals 1.48 atmosphere. So we get the answer for the second part first, which is equal to pressure inside the gas or inside the cylinder of the gas finally is equal to 1.48 atmospheres. Now we try to find out what is the volume of gas which has been used up. Now, since the gas which is leaking has pressure equals 1 atmosphere, let us say the volume of gas which is getting leaked is equal to V. The temperature is equal to 300 Kelvin only. Now the weight of gas which has been used up or which is leaked is equal to 14.2 minus 8.5 kilograms, because 14.2 was the initial weight of the gas inside the cylinder and 8.4 is the final weight of the gas present inside the cylinder. this comes out to be equal to 5.8 kilograms or 5.8 into 10 power 3 grams. On dividing it by 58, we get the number of moles. So using PV is equal to nRT again for the leaking gas, we have 1 into V is equal to, this is 100 into 0.0821 into 300. So our volume comes out to be equal to 2.4 into 10 power 3 liters. And this is the answer for the first part, that is the volume of gas that has been used up. It is equal to 2.4 into 10 power 3 liters. And the answer for the second part, that is the pressure final of the gas present inside the cylinder, is equal to 1.48 atmosphere, and these two are our final answers.